Okay, so this video goes over how to find the x and y intercepts. So it's part A for a straight line. So what are we talking about here? Well, if we have a look at a straight line, the x-intercept is where the straight line cuts the x-axis. And you can see that's where that green dot is. The y-intercept is where the straight line cuts that vertical y-axis. And that's called the y-intercept. We tend to write them as those points, so that green point and that red point, as a coordinate. So if you have a look down here, this is a specific example of a straight line. This coordinate here, this x-intercept, so where the graph cuts the x-axis, so it cuts it at the coordinate x equals minus 4, the value x equals minus 4, the coordinate is minus 4, 0. So x is minus 4, y is 0. And the y-intercept, so up here, where it cuts the y-axis, is where y equals 6, at that value there. Or the coordinate is 0, 6. So x equals 0, y equals 6. So one thing to note is whenever you have an x-intercept, the y value will always be 0. Whenever you have a y-intercept, because it cuts the y-axis, the x value will always be 0. Now, there's a few ways to find the x and y intercepts, more than one way, but we're going to focus on using graphmatica. So if we go to, I'm just going to delete this graph, so right click, delete graph. All right, so I'm going to use the worksheet that you have. You're going to do part A of this worksheet once you've finished watching this video. So part A, you'll be using graphmatica to graph the following equations below and write down the x and y intercept of each equation, writing them as a coordinate. So I'm going to do part A for you. So you've got y equals 2x plus 1. So this one here, y equals 2x plus 1. What I'm going to do is I'm going to open graphmatica, and we're going to type that equation in. So y equals 2x plus 1. We type it in the y bar at the top. Press enter, and it's graphed it for me. Now, I need to write down the x and y intercepts. A lot of the time, you can just read it off the graph, because I can see clearly that this x value is minus 0.5, and this y value is 1. So the coordinate down here is minus 0.5, 0. So x is minus 0.5, y 0. I can even put my cursor on top. And if you have a look down on the bottom left-hand corner of the screen, you'll see that coordinate there, minus 0.5, 0. And that 0 in blue represents the fact that it is the x-intercept. So I can write that in. So minus 0.50. So let's go back to my minus 0.50 down here. Zero. And let's find the y-intercept now. So I can put this cursor on top, and if I look down in the bottom left-hand corner, it's 0, 1. You could probably even read that from the graph. 0, 1. So if I go back to here, I can type that in. 0, 1. 0, 1. So that's the coordinate of the y-intercept. Say my graph wasn't very clear, I could also do it another way. I'm going to show you this. It's handy to know how to do this. If you go Tools, up here, Evaluate. So you can see the equation is here. You can select other equations by just clicking on that down arrow. But I want this equation, 2x plus 1, 2x plus 1. Solve for y. So when x equals 0, what is the y value? In other words, what is the y-intercept? Because the y-intercept is when x equals 0. We press calculate, and it gives me the coordinate 0, 1, which is the y-intercept, which we wrote here, 0, 1. We can then go back and find the x-intercept this way. And the way we find the x-intercept is it's just Tools, Evaluate, but you click the second option. So you press 0, type 0 in there. So when y equals 0, what is the x value? So when y equals 0, that's actually when you're finding the x-intercept. So when y equals 0, press calculate, and it told me error. That does happen sometimes. I'm just going to get out of this. Tools, evaluate. Type in 0 there. Let's try this again. Calculate. There we go. So if you get an error, just go back out of it again and press Tools, evaluate, and then select the second option. So I typed 0 there, and it gave me the coordinate, minus 0.50. So there's more than one way. You don't have to do it all of these ways. You can, option 1, put your cursor on top and see if you can read it off accurately on the left-hand side, on the bottom, on the left-hand side, right at the bottom of the screen. So you can do it that way. You can also just read it off your graph if you can see it accurately. And the third way is to go Tools, Evaluate, and to pick either one and put 0 in each of those. But again, you might need to go back out and go Tools, Evaluate to do it the other time. So that is for part A. Of course, for part A, for question 1, I should say. Then if you want to do part B, so question 1, part B, so y equals 0.2x minus 8, you can delete that graph, right-click delete graph, and you type the next one in, y equals, etc. Okay, and then you need to write down, just follow the same steps again, pick whichever method you like. Tools, evaluate is always a good one to do, but you can use the other methods, and you can write down the x and y intercept. Another thing to note as well, when it's written in this form, the equation y equals, when it's written y equals and there's no number in front of the y, except there is a number, there's a 1 in front of the y, so there's a 1, it's 1y there, but not another number. When it's written in that form, you can actually read your y-intercept off here as well. That's from a previous lesson. You may or may not remember that, but that's just something algebraic to remember. The y-intercept is 0, 1, which when it's written in this form, you can read it off there as well. That doesn't always help you when you have questions like in D and E, but you can work them out algebraic as well. That's a bit of an extension. So that's question 1. Then if we move down, question 2, I will help you out with this one. It says, write the equation of the line that passes through the points 1, 2, and 6, 8. All right, so some of you might be able to do this algebraically, using algebra, that is, but I'm not expecting you, and your teachers are not expecting you to do it this way. We're going to get you to use graphmatica. So I've put a hint here. Go back to lesson 1. So view data plot editor. So that's where you added in points. So the coordinates are 1, 2, and the other coordinate is 6, 8. So if you go to graphmatica, view data plot editor, you type in the points 1, 2, 6, 8. When you do that, they come up, and you can see I can't see 6, 8. If you want to see the point, you don't actually need to in this case, but if you want to, you can either zoom out or you can go to it is view grid range. Change your grid range if you want to see the bottom of that. So it was actually the top part actually. So 1, 2 we can see. We just can't see 6, 8. So 1, 2, what can't we see? 6, it's still not high enough. You can zoom out if you like. I just want to see my coordinates. So I'm just going to view, grid range, and y, it's 2. Actually, I can just see it right at the top. That needs to be higher. So let me put 10. You can see that just there. So the top. Okay, so I can see my 2 points. So they're the 2 coordinates. And remember, I did that by going to remind you, we go to, where is it? We've got view data plot editor. That brings up this screen here. We type in our coordinates. Then you go to curve fit. You should have already set it to straight lines from lesson 1. If not, go back to lesson 1 in order to set it as a straight line. But you don't need to do that again if you've done that from lesson 1. Graphmatica will remember that. Just click curve fit, and it will put your straight line through those 2 points. And if you hover over the line, you can read your your equation on the bottom left-hand side of the screen. I'll just delete that. So that is really how, if you have 2 points or 2 coordinates, you can graph the straight line that goes through them, and hence you can find the equation that goes through them. So what you need to do is you need to do that, and then you need to graph your equation and paste it below. In question 3, 4, and 5, I only give you 1 coordinate, and I ask you, what is a possible equation that could go through that line, through that point? What is a possible straight line that could go through the coordinate 0, 4? You might be able to think of one without actually using graphmatica, but you can use graphmatica. So say we've got 0, 4. So if I want to delete these, I just right click. Actually, no, yes, just delete, sorry. Just hit this button up here. So it said 0, 4. And I didn't say the other point. So you can pick any other point you like. So I could pick 1, 3. You can pick any other coordinate. So the first coordinate I've given you, the other coordinate is optional. Okay? And then I put curve fit, and then I've got the straight line. If I hover over it, I've got the equation down the bottom. The equation down the bottom is y equals minus x plus 4. But again, you could have a different equation to me. Your graph could be going in the other direction. So this is a negative gradient. You could have one going in the positive direction, depending on what your other coordinate is. So if you have a look at, when you have a go at question 3, you'll see that we've put there that there is more than one answer. It's an investigation type question for question 3, 4, and 5. There's not just one answer. Okay, so have a go at part A now, and so open the worksheet, have a go at part A, and once you've done that, you can watch the second video.